Math 2414, arc length, video 3. Arc length example 2. Find the arc length of g of y equals y cubed over 3 plus 1 over 4y on the interval 1 is less than or equal to y is less than or equal to 2. Now, you might be going, that's not a function, that's not f of x, and my reply would be, you're right, but it doesn't matter. Even though our arc length formula is in terms of a function f of x, and is in terms of x, the name of a function and the name of a variable is completely irrelevant from a theoretical perspective. Who's to say something had to be a function of x when it could be a function of y? Who's to say it had to be called f when it can be called g? The important thing is we have a function and an interval over which to calculate the arc length. So, everything here will be in terms of y, but the technique won't change at all. Alright, speaking of the technique, to set up the arc length interval, we have to calculate the derivative of the function, square it, add 1 to it, and park all that under a square root. So let's start by finding the derivative of g. But before we do that, we might want to rewrite the second term. In fact, I'm going to rewrite the first term as 1/3 y to the third. But guess how I'm going to rewrite the second term? Make sure I copied this problem. Yep. Guess how I'm going to write the second term? As 1/4 y to the negative first power. Do you have to do that? No. Do you really want to use the quotient rule on this? You could. But why use the quotient rule when I can just move the exponent up top, make it negative, and just use the power rule? Alright, so after rewriting our function in terms of powers, then we can take the derivative. The derivative of 1/3 y to the third is just y squared. And the derivative of 1/4 y to the negative 1 is negative 1/4 y to the negative 2. Okay? Could we rewrite that as fractions? We could, but think about what we're going to do next. We're about to square the derivative. So let's do that. By squaring this binomial. Now we could write it twice and FOIL it, but I'll be honest with you, by this point in your math career, you should know how to square a binomial. So if you don't know the following, you should. When you square the sum of two terms, it's the squares of the first and the last, and then twice the product in the middle. And when you square a difference, like a minus b squared, it's still a squared and plus b squared, but the middle is minus 2ab. It's just so much more convenient to think that than to write it out as a FOIL problem and do it. But if you forgot that, you can write it out as a FOIL problem and do it. So let's square this. If I square the first term, y squared squared is y to the fourth. If I square the last term, which by the way is the reason it comes out positive, the negative squared is positive. If I square the last term, it becomes positive. 1/4 squared is 1/16. And y to the negative 2 squared, if I multiply the exponents, I get y to the negative 4. And in the middle, we get minus 2 times the product of the two terms. So minus 2 y squared 1/4 y to the negative 2. So the mess is in the middle, but it's going to clean up fairly nicely. We get y to the fourth. Let's start with the 2 times 1/4. 2 times 1/4 is 1/2, so minus 1/2. Well, what happens to the y's? We add their powers. Y squared times y to the negative 2 is y to the 2 plus negative 2. But 2 plus negative 2 is 0, so we get y to the 0 power. But anything to the 0 power is 1, so we get 1/2 times 1 is just 1/2. So in other words, in the middle, all the y's cancel. It makes sense if you think about the y to the negative 2 as 1 over y squared, and then the y squareds would cancel. And then plus 1/16 y to the negative 4. So a little bit of algebra in the middle, but nothing that you shouldn't be able to handle. Let's see, where are we? Oh, we just found the square of the derivative. Now we have to add 1 to that. Oh, by the way, don't write this. I see people in my homework doing it and I call them out on it. You need to think of equations as sentences. When you stop one, start another. This string of things are not all equal. These aren't equal. Actually, this is the only place where we lose the equality. I take that back. These aren't equal either. We did a new move. Here's the function, period. Here's its derivative, period. Here's the square of the derivative. Now here, we can keep a sequence of equal signs because all of these things are equal. But anytime you start to something new that's not equal to what was previous, don't tell me it is. I will call you out on it. I say that because then we're done squaring this binomial. Our next move is to add 1 to it. So now we end that sentence and start another one. 1 plus the square of the derivative is equal to all this plus 1. But think about it. If I add 1 to this, I have to add 1 to that, and there's a constant in the middle. So really, I just have to add 1 to the middle term. Well, what's negative 1/2 plus 1? Positive 1/2. Oops, that's y to the negative 4. Okay, this doesn't look that bad, but keep in mind that before we integrate this, we have to park this under a square root. And parking all that under a square root inside of an integral is going to get real ugly. Unless you're really observant. This is a trinomial, and it factors. And not only does it factors into a perfect square. Wait, what? Look at the trinomial we currently have and the one we just had before it. The only difference is the sign in the middle. Well, this guy was a result of squaring that binomial. Guess what this guy is? Actually, you shouldn't have to if you look over here. The only difference between these squared binomials is the sign in the middle. The only difference between these trinomials is the sign in the middle. So this guy will instafactor into y squared plus 1/4 y to the negative 2. Because the only difference between these squared binomials results is the sign in the middle and vice versa.